Lesson 15, elimination. This is another way to solve linear equations. Okay, this is an equation and we've got an x and a y value. All right, so we are solving linear equations. We talked about the substitution method the other day, and today we're going to talk about elimination. We can eliminate a variable by addition, okay, also called linear combinations. Okay, so variable terms can be eliminated by addition. Or subtraction. Okay, now keep in mind that in order to eliminate a variable, in order to add or subtract it, both coefficient terms need to be the same. For example, a 4x term and an x term, if we're trying to eliminate, well, how do I get rid of 4x? I take away 4x, okay? So the coefficients on these variables need to be the same. What happens if we don't have like coefficients? All right, well, keep in mind that every term in an equation can be multiplied by the same number without changing the value of the equation, okay? So every term in an equation can be multiplied by the same number without changing the value of the equation. Every term in an equation can be multiplied by the same number without changing the value of the equation. So in order to get those coefficients to be the same, we would multiply the entire equation by a certain number. All right, let's just do a couple examples to work through this. All right, in the first example, we have the equation 2x plus y equals 11, and 3x minus 2y equals 6. All right, now, we did the substitution method previously in this particular equation. In the first one, y would be ideal for solving via substitution. However, we're going to solve this by elimination. Either way you solve it, substitution or elimination, you're going to get the same solution. Okay? Just make sure you're following directions when it asks you to solve by substitution. Make sure you solve by substitution. When it asks you to solve by elimination, make sure you're solving by elimination. Okay? So in this particular equation, we got to choose a variable term to eliminate. Do we want to eliminate the x terms or do we want to eliminate the y terms? I'm going to choose the y terms for this reason. Even though the coefficients are not the same, their signs are opposite. Okay? This is ideal for elimination because if I have a plus, the only way to get rid of the term is to take it away. Okay, so we need that subtraction. Now I need my coefficients to be the same. Okay? In the bottom equation, I have 2y. In the top, I have 1y. If I change the top equation so that there's a 2y, I can solve by elimination. Now, how do I make this a 2y? Well, if I multiply the entire first equation by 2, that's going to change my y into 2y. All right, so we're going to distribute this 2 in. 2 times 2x gives me 4x. 2 times y gives me plus 2y, and 2 times 11 gives me 22. Do not forget to distribute to every single term in the equation. All right, so now I have 3x minus 2y equals 6, and 4x plus 2y equals 22. I'm going to combine these, okay? We're going to do linear combinations, or we're going to add the two equations together to get the y values to cancel out. All right, so let's start with 3x and 4x. Okay, if I add these together, positive 3 plus positive 4 gives me 7x. Now in the middle, I've got negative 2y plus positive 2y. Well, negative 2 plus positive 2 is 0, and so that cancels out my y term. Bring down the equal sign. 6 plus 22 is 28. Now we can just solve for x. All right, in order to get x by itself, we divide by 7. So x equals 4. Okay? Once we solve for x, we go ahead and substitute it back into an equation, either one, in order to solve for y. All right, so I'm going to go back to my first equation, 2x plus y equals 11. And I'm going to substitute 4 in place of x. 2 times 4 is 8, so I have 8 plus y equals 11. Subtract 8 from both sides, and y equals 3. All right, so we have our x value, we have our y value, and keep in mind, still, we're writing these answers as an ordered pair. Okay, so it would be 4 and 3. And that is my final solution for this equation. Now let's look at a second example. In this example, we have 3x plus 2y equals 23, and negative 2x plus 3y equals 2. All right, we're going to solve this by elimination. And in this case, I'm going to choose the x term to eliminate because the first x term is positive, the second x term is negative. That allows for easier elimination. However, the coefficients to the variables are not the same. Okay, so we need to get them so that they are the same. Well, there's nothing that I can multiply 2 by that will give me 3 unless I multiply by a fraction or mixed number. And there's nothing that I can multiply 3 by that will give me 2 unless I use a fraction or mixed number, which just makes things messy. So we're going to choose a common multiple. Well, 2 and 3 both go into 6. So I'm going to change both of these coefficient terms to 6. Well, what do I multiply by 3 to give me 6? 2. So I'm going to multiply the entire first equation by 2. And what do I multiply times 2 to give me 6? Well, that would be 3. So I'm going to multiply this entire second equation by 3. Keep in mind that you need to multiply every single term. All right, so in the first equation, 2 times 3x gives me 6x. 2 times 2y gives me 4y. And 2 times 23 gives me 46. All right, so that's my first equation. In the second equation, 3 times negative 2x gives me negative 6x. 3 times 3y gives me 9y. And 3 times 2 gives me 6. All right, so now I have same coefficient, different signs in my x values. So we're going to do a linear combination, or we're going to add the two together. Well, 6x minus 6x is nothing, and that eliminates our x terms. All right, so then we have 4y plus 9y is 13y, and 46 plus 6 is 52. We divide by 13, y equals 4. All right, now that we've solved for y, we can substitute it into another equation and solve for x. I'm going to go back to the first equation, 3x plus 2y equals 23. All right, we're going to substitute 4 in the place of y. So we have 3x plus 2 times 4 equals 23. And then we just solve as usual. All right, 2 times 4 is 8. We subtract 8 from both sides to get that variable term by itself. We have 3x equals 15, which means that x equals 5. All right, and again, we need to write our answer as an ordered pair. So it would be 5, 4. And that is the final solution. All right, this next example, I would like for you to try to work on your own. All right, we have 4x plus 3y equals 17. And negative 3x plus 4y equals 6. Go ahead and use the elimination method to try this one by yourself, and we're going to check it when we come back into class.